Okay, good afternoon, everybody.
Good afternoon.
Looks like everybody was sleeping out there. Welcome again to our Entrepreneurial Bootcamp series. This is, I believe, our last one. Thank God for that. No, it's been fun. I think it's been a learning experience, hopefully for us as well as for all of you. Our today's session is on cybersecurity for smart grids, building a successful business plan and model, and hopefully we can see if there's ideas that come out of some of the discussions here for building the business that we're talking about. We have a very good and very diverse group of panelists that cover everything from the law aspects of smart grid and cybersecurity, as well as actual implementers, people from utilities and the New York ISO, as well as somebody that's actually involved in trying to set the vision for the smart grid for the future. So we're going to have hopefully a good interactive discussion moving forward. Again, I want to sort of thank our sponsors. We have NYSERDA that actually funds the incubator that we have over here, and the bootcamp series is part of that. I also want to thank Albany Law School for this session. They've been involved with, or partnered with us on this specific session, this bootcamp session that we have here. I want to move forward and introduce our first panelist. Our first panelist is Dr. Mary Reedy from National Grid. She is a member of the Smart Technology Center in Liverpool, New York, which is part of National Grid, and she's also responsible for identification of appropriate university-industry collaborations, and she's going to obviously talk about all the collaborations she has with a bunch of different universities, including some of the stuff she's looking at doing with us. And also she's involved with the Smart Grid curriculum as part of the U.S. Department of Energy's grant that they actually have. She is currently serving as chair of the IEEE P2030.1 working group. This working group will provide a guide to those interested in the interconnection and interaction of electric transportation and the electric grid. So she's heavily involved with EV aspects of electric vehicle aspects of the grid. She's an active member in the IEEE Education Society, member of the Academy of Management, a reviewer for published papers in AOM and IEEE Engineering Management Society. Mary is a licensed professional engineer in New York State. She has earned a PhD, an MBA, and engineering, a Bachelor in Science, all in electrical engineering except for the MBA, a BS in accounting. Mary.
Thanks, Brittany. Appreciate it very much. So thank you everyone for coming. Please feel free to relax and enjoy the presentation and look forward to your questions. And just to advance the slide. Okay. So I've got about 10 minutes just to bring you up to speed on some of the things that we're working with on cybersecurity. Just for a reference point, I do not handle the cybersecurity aspects at National Grid. We have three really great, fantastic people that handle that, but each of them had time conflicts, and one of them actually had an appointment with his dentist today. So I recommended that he not make the dentist upset and go to the appointment. So I'm subbing for them, and I've decided to take maybe a little broader view for you to help to set the stage for some of the more detailed discussions that you'll hear this afternoon. So we'll start first with a couple definitions, because I'll tend to use the acronyms, and if they get to be too much, just stop and let me know, and we'll take a step back. So a couple of them that we're going to talk about: NIST, National Institute of Standards and Technology; SGIP, Smart Grid Interoperability Panel, or if we're talking about specific procedures, then it will be procedures. IEEE, Institute of Electrical and Electronics Engineers. Those are the group, that is the group that's looking to help to advance standards for some of the cybersecurity and smart grid initiatives. And last one, Department of Energy, which is very interested in the development of smart grid as a way to move the economy forward and to really start to kind of kickstart the innovative aspect of what smart grid could actually deliver. So what you're going to see here, anybody in the back read this really well? Probably not, right? I have a hard time reading it on my desktop. But what this is trying to portray is that smart grid, the entire concept, looks to link what we call an end-to-end approach in the electric power industry with some of the other supporting technologies like communications, IT, some of the electric vehicle, energy storage, renewable energy concepts. So when people are talking about smart grid, as it's defined both from the IEEE and at National Grid, we're really looking at a very integrated, holistic approach and not just smart meters. What I want you to see here with this particular diagram, little table, is that unlike many very specific programs, there is not one leading agency for development of smart grid policies, technical standards, guide points, and really technology development, but rather there are multiple agencies, both at the federal, at the state, local, and also in the technology space. And all of them have opinions and expertise in their areas. What's very unique about smart grid is it actually presents a fantastic opportunity if you happen to be a technologist in one particular area, like information technology, and you always wondered about how the power system was operating. This is a fantastic opportunity for you to have that conversation with the power engineers and actually to move it forward. So what do we want to talk about when we say we're looking at an interoperability panel? Why is that important? Well, many times you will have technologies that will operate as standalone units. And with smart grid, what we're talking about is actually having the ability to collect data through a meter on not only home energy usage, but also commercial, industrial, typical generation, fossil fuel, renewable, biomass, hydro, wind, solar, and all of those particular products actually have very different waveforms and very different dynamics to be able to pull them together and actually allow them to communicate to each other, send the information back to the utility, and have the utility be able to operate and to really integrate what the data means, and then to be able to communicate back to the unit and back to all the other actors that are in that space is quite a daunting task. So within that entire space of smart grid, we also talked about the IEEE, the engineers group. These are electronics engineers, a lot of power engineers, and they've actually set out a space where they're going to deal with smart grid and try to pull in all of their expert technology contributors in what they call working groups. The overarching working group is referred to as 2030, IEEE P 2030. And that will look at things like power technology, information technology, and communications aspect. When they started to look at that broad approach, they also realized that there were some non-traditional electric technologies that were surfacing that really needed to be integrated. One of them is P2030.1, which, as Pradeep said, this is the one that I chair. This is looking at the potential impact of electric technology on the electric system, whether it be generation, transmission, distribution, or the consumer space. And so we are working collaboratively on that group. There's approximately 230 members. They're international in scope, and we have a goal to actually develop a guide that will talk about not only electric vehicles, but also the battery storage technology, the driving factors for generation, transmission, distribution, and the consumer space, and all those other pieces in between. In addition to the electric vehicle component, there also is a P2030.2, which is looking at energy storage. And so if you're interested, you can talk with me after the discussion, and I will get you to the right people and plug you in so that you can be part of that and contribute to that development. We talked a little bit about this National Institute of Standards and Technology. We commonly refer to this as NIST. NIST was approached by the Department of Energy a few years ago to look at important concepts on cybersecurity. So in addition to the work that they were doing to help to advance the collection of all the standards that were in the space, there was a driving concern that cybersecurity was going to be so important, so innovative, and really so new to that space that they needed to pull it out and have its own little charge and its own little organization. And so what they did was they said, with cybersecurity, we're going to actually develop what they call a NISTIR, N-I-S-T-I-R 7628. And we will actually develop that for guidelines on cybersecurity. Right now, Chapter 1 is complete, Chapter 2 is under final review, and Chapter 3 is forthcoming. If you're interested in those types of technologies, I've listed a couple of reference links, and we can have a discussion about those as the panel evolves. Pradeep?
Thank you, Mary. Good introduction. Our next panelist for this afternoon is going to be Ryan Smith. They're all looking at me trying to guess which one's going to go up next, I guess. Ryan Smith serves as Manager, Infrastructure Services at the New York Independent System Operator. In this capacity, he is responsible for directing the operation of complementary and coordinated teams providing 24/7 by 365 support of the organization's infrastructure and assets used for bulk power markets, trading $7.5 billion annually in reliable dispatch of over 500 electric power generators on New York's nearly 11,000 miles of high voltage transmission. Ryan is accountable for enterprise security and all facets of system resiliency, including high availability and disaster recovery of the data centers. He has 15 years of information technology experience with over 10 years at the ISO. He's a member of the Security Working Group of the ISO RTO Council and is a member of the Northeast Power Coordinating Council's Task Force for Infrastructure Security and Technology. Ryan holds a Bachelor of Science degree from RPI and a Master of Business Administration from the Graduate College of the Union University. Ryan?
Thank you all for having me here today. Wanted to give you just a little bit of a background on who we are at NISO, what we do. I'll tell you a little bit about our smart grid project and some of the issues from a cybersecurity perspective. So real quick, run through these for you. So at the NISO, we have really four main roles at the NISO. We're responsible for reliable operation of the bulk electricity grid, so reliability comes first. We want to make sure we keep the lights on. We're also responsible for administration of open and competitive wholesale electricity markets. This is not what the retail customer deals with, but what the transmission owners and the generators, that level of interaction. We also have a transmission planning group that's looking at New York's energy future and planning out long term, looking at the units that are coming offline, what new units have to come online, what kind of demand, and how that's going to change things going forward. And of course, we have a role in advancing the technological infrastructure of the electric system. And so for me, I'm an IT guy, and the technology part is certainly what interests me and what really motivates me to go to work every day. The NISO Smart Grid project, we're working on a $75 million project to enhance grid reliability and efficiency. That project involves us working together with all of New York's transmission owners. We were awarded a U.S. Department of Energy Smart Grid investment grant to cover half of the cost of that project. And it involves the deployment of a statewide phaser measurement network. The idea there is to enable us to gather more information in real time about what's going on the grid and get that to our grid operations people.